Hey, eighth grade, let's dive right into solving systems. So our first method is by graphing. So we're going to graph some systems of equations. Here's some vocabulary. We're going to talk about systems, solutions, consistent, independent, dependent, and inconsistent systems. So pause, write, push play again when you are ready. And I am moving on. All right, so example 1. What is the solution of the system? Use a graph. So how do we use a graph to find a system of solutions? So step 1, graph both lines. And you want them on the same graph. So here I have a slope of 1 and a y-intercept of 2. And so I'm going to go to the 2, and I'm going to go up 1 over 1. And I'm just going to tell you that the more points I put, the straighter my line's going to be, but also there's a chance I'm going to cross and it'll make it easier for me to know where my lines cross. That's the one thing, like when we're doing these by hand, is if we don't have our lines going really straight, we may miss where our lines actually cross. And so that's part of the reason why I draw my dots all the way. All right, and then we've got m equals 3, mb equals -2. So we're going to go down to the -2, and then up 1, 2, 3, and over 1, up 1, 2, 3, and over 1, up 1, 2, 3, and over 1. I'm going to do it one more time. Then I'm going to go a couple this way, 1, 2, 3, over 1, 2, 1, 2, 3, over 1. All right, and then I'm going to do my best to draw this line. This is when I would wish that I could do this with a straight edge. All right, so here's our line. And again, the lucky part is I know that both graphs crossed here because I put a dot both there. And so that's what our solution is. That's where our lines cross, so that's our solution. And so we're going to take the point, and our point is 2, 4, right? X, y. So 2, 4. Now, if I'm like, ooh, I'm not so sure, all I have to do is plug them in. So 4 equals 2 plus 2, and so then 4 equals 4, so that one's good. And then I plug it into the other one. 4 equals 3 times 2 minus 2. 4 would equal 6 minus 2, which is 4. And so by checking both of those, which you can do in the calculator, I just write it out because then you know what I'm doing. But by knowing that the left equals the right, that tells me that that is a solution to our equation. So number 1, graph both lines. Part 2 would be to find where they cross. All right, on to the next. Scientists studied the weights of 2 alligators over a period of 12 months. The identical weight and growth rate of each all right, whatever. I think I have a typo. Of each alligator shown below. After how many months did the alligators weigh about the same amount? All right, so I am counting by ones. I'm just going to put a 1 here and a 1 here so we know we're counting by ones. I'm going to take the information in the picture and I'm going to say for alligator 1, y is going to equal, we know that the initial weight is 4 plus 1.5 per month. Now, I know that my slope 1.5 is the same as 1.5, which is 3 halves. So I'm going to change it to 3 halves so I can count the slope, and b is 4. So for my first alligator, I'm going to start at 1, 2, 3, 4, and I'm going to go up 3, 1, 2, 3 over 2, and up 3 over 2, and there's my first line. Now, why am I only in the first quadrant? Because you can't have negative alligator growth. That's why. All right, number 2, y equals, it has an initial weight of 6, and a rate of growth of 1 pound per month. So 1x. So my M is 1 and my B is 6. So I'm going to, that's 4, 5, 6. And we're going to go, oops, no, come back. 6, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And so, and I know they're not that straight, but they do cross right here. And then the question is, after how many months? So our months is our x value, right? This is our x value. So I just need to know, I follow my line down. What's my x value here? 1, 2, 3, 4. And so it will take about 4 months. And then they'll be the same weight. All right, so real quick key concept. We have 3 types of solutions. You can have one solution, which is what those last 2 we just did, where we cross out 1 point. This is what we call a consistent independent. Because it has at least one answer, and it's independent because it has exactly one answer. Other things to note about a one solution, our slope is always different. Our y-intercept can be both different or the same. Now, for infinitely many solutions, it looks like it's just one line, but really that it's purple because it's both the red and the blue right there. And so this is what we call a consistent, because it has at least, but in this case it has many answers. A consistent dependent, because it has infinitely many solutions. Our slope for this one is the same, and our y-intercept is the same. It's basically the same all around because it's the same line. And then our no solution, this is what we call an inconsistent. Oops, I looked away and I think I just spelled that wrong. Go look up how to spell it on that first slide. For this, our M is the same, our slope is the same, but our y-intercept will always be different, because to be parallel, well, these would be parallel lines. That's what they are. And so to be parallel, you have to have the same slope, but different lines. All right, moving on to our very last questions. So what is the solution to each of these systems? I'm going to rewrite this first one as y equals. So I'm going to add x. So I got 2y equals x plus 2, divide by 2. So y would equal 1/2 x plus 1. Now if you notice, that is the exact same as this above because we have the same slope, same y-intercept. And so that tells me that this is an infinitely many solutions. Now, if you're having to graph it, then that graph starts out 1 and goes up 1 over 2. And so there's an approximation of a graph. All right. When we look at this one, we have same slope but different y-intercepts. So that means that this is a no solution or an inconsistent. And if we were to graph this, we would start at 2 and go up 2 over 1. So we would have about that line going on. And then we'd also have one starting at -1 and going up 2 over 1. And in all honesty, they would never touch, and they wouldn't even come close to it. So no solution, same slope, different y-intercepts, graph parallel lines. Infinitely many solutions graphs the same line because it has the same slope, same y-intercept, and then you have your single solutions which have different slopes and either the same or different y-intercepts. And that's what I got for you today. That's how we graph. See you on the flip side.